Another common way to present a relation is with an equation in two variables. And this is something that we saw in the last unit with lines and their graphs. We could, for example, consisting of all pairs xy, such that 2x plus 3y equals 6. Now I hope that this notation is something that you've seen before. This is called set builder notation, and we'll be seeing more of this shortly. So what is this? Our set builder notation, right, it starts and ends with set brackets, and then in between the set brackets we have two parts. This part x and y, and then this part, which is an equation, and this vertical line. Right, so the set brackets just keep everything enclosed. Right, the vertical line, which we read such that, separates the parts. The xy, which comes before such that, gives a basic form for things in the collection. So when we see xy here, we know that things in the collection are going to be ordered pairs. If we saw just an x there, we would know that things in the collection were going to be numbers. If we saw something more complicated there, we would know that things in the collection were going to be something more complicated. And then the 2x plus 3y equals 6 gives a condition for being in the collection. So in this case, in order to be in the relation R, x and y have to have the property that when we multiply x by 2, multiply y by 3, and add those together, we get 6. So, for example, 1.5 is related to 1, because if we take 2 times 1.5 plus 3 times 1, well, that's 3 plus 3, which is 6. We also could say, for example, 3 is related to 0, because 2 times 3 plus 3 times 0 works out to 6, and so on. Right, we could also say, for example, that 2R5 is false. Why? Because 2 times x plus 3 times y, well, that works out to 19, which is not 6. Right, so 2 is not related to 5, 3 is related to 0, 1.5 is related to 1. And notice we didn't need to do any algebraic manipulation of this equation to determine whether two given numbers were related. Let's see another example. Let's suppose S is the relation defined by x is related to y when y equals 1/2 x plus 3. Then we see 2S4 is true, since 4 is equal to 1/2 times 2 plus 3. 3S5 is false, since 5 equals 1/2 times 3. Since 5 is not equal to 1/2 times 3 plus 3. Right, this is 4.5, which is different than 5. We could be asked to find y, such that 4 is related to y. Well, y is in the second place. It would be not mathematically wrong, but extremely rude to write y in the first place, so we're not going to do that. So y is 1/2, 4 is in the first place, A half times 4 is 2, plus 3 is 5. And now, there's no getting around that with this equation. Y equals 5 is the only such y. We could also say, find an x such that x is related to 3. Well, we have 3 is in the second place, so 3 is a value of y. But x we don't know. We can solve this for x, can't we? We can subtract 3 on both sides. We get 0 is 1/2 x. Dividing both sides by a half, we get 0 equals x. And again, we see that x equals 0 is the such x. Now, that wouldn't necessarily always be the case. Let T be the relation consisting of all pairs x, y, such that x squared plus y squared is 25. I'm going to have you try a couple of things with this. First, I'm going to have you check whether each of the following statements is true. Check if 3 is related to -4, if 0 is related to 5, if 4 is related to 2, and if 6 is related to 1. Pause the video and try this now. All right. So, in this first one, 3 is in the x place, -4 is in the y place. We'd like to know what 3 squared plus -4 squared is. Maybe we can do that in our head, or maybe we'd like to use the calculator. Notice I put the -4 in parentheses because I want to square the entire -4. And I see that I get 25, which is the equation that is the condition for my relation. So yes, this is true. Next question. 0 in the x place, 5 in the y place. This one I can do in my head, right? This is 0 plus 25 is 25. How about these two? 4 squared plus 2 squared is 20, which is not 25. So no, these are not related. 6 squared plus 1 squared. 6 squared plus 1 squared is 37, which again is not 25. So no. We can also ask some more complicated questions. We could say, name 2 values of y such that -4 has relation t to y. We could ask the question, is there any number x such that x is related to 6? Pause the video if you'd like and think about these 2 questions and how we might answer them. Okay, so question number 1, we're looking for a number y so that -4 squared plus y squared is 25. Well, we know how to isolate y squared, so let's try that. -4 squared, that's 16. Subtract 16 on both sides. We have y squared equals 9. And we don't really know what to do with that right now. But if we think for just a little while, we know one number that when we square it, we get 9. 3 squared is 9. Can you think of another number that when we square it, we get 9? Yeah, -3 squared also equals 9. So we could have y equals 3 or y equals -3, just by guessing. Let's try the same thing with this guy. Right, we're looking at for an x, so that x squared plus 36 is 25. We're looking for an x, so that x squared is negative 11. Wait a minute. What happens when we square a positive number? Yeah, we get a positive number. How about if we square a negative number? Still positive, right? Like negative 3 times negative 3 is positive 9. 0 is the only thing that's left, and that squared is just 0. There isn't anything we can square and get negative 11. So no, there is no such x.